Good afternoon. I'm Mario Bourgoin, the Partner Global Tech Lead for MLOps. Today, I'll talk to you about third-party tooling use with SageMaker. So there are two basic kinds of tooling that I'm going to be looking at. One of them is about MLOps orchestration and third-party tooling for MLOps reproducibility. I'm going to do this in the context of what SageMaker can do, so then you can also compare that what will you get um, with the third party. So starting off in MLOps orchestration, there are two kinds of options for orchestration. So you can orchestrate with AWS managed tooling, and that's a good thing, or you can orchestrate with third-party tooling and open source. So Kubernetes is open source, kubeflow pipelines, Airflow. If I remember correctly, weights and biases is based on open source. Can you correct me on that, Chris?
Hey Chris, there was a question
Oh, I'm sorry.
if the weights and biases is also based on the open source project. Maybe it's better like. Is it a great question?
It's we're a B2B SaaS company, so it's not fully like our code base is not open, but a lot of our tools are somewhat open sourcey. I don't know how to answer that question honestly.
So you're a mix.
Yeah, a bit. We have.
But if we want to take what?
We have components that are open source.
Right. But to take full advantage of weights and biases, of course, I'd have to be using your servers and your components that exist with your servers and the whole story. It's not just good enough. Okay, so you're not open source, you're a mix. That's fine. Thank you for the clarification.
Of course.
Okay, so what do we expect of an orchestration tool for machine learning? Can't we just use a DevOps orchestration tool? Well, ML has needs beyond DevOps, so you need to augment that DevOps tooling. The most important need for our purposes is lineage tracking to help fulfill the responsible AI goals that come from the fact that machine learning is different in that it makes decisions. So let's look at ML workflow orchestration. SageMaker Pipelines is an exciting feature that we introduced at reInvent 2020, 2 years ago now. I'm sorry, I'm hearing a chair rubbing along or dragging. Is there? Okay. If no. Okay. There's something funky going on with the table, and it records everything that you do on
I think it's coming from the meeting room itself. I can see the microphone changes when the sound happens. So maybe we
Exactly.
can, people in the meeting room, mute the microphone till they speak, if you don't mind.
Oh, okay. Thank you.
Thank you. I really appreciate that sound. Okay, that's so cool. Thank you. So SageMaker Pipelines is an exciting feature that we introduced at reInvent 2020. With pipelines, data scientists and machine learning engineers can codify their workflows into repeatable, trackable pipeline. SageMaker Pipeline covers the whole life cycle of a model, all the way from retrieving and processing data through almost at deployment. Actually, I can actually make it deploy, but let's leave that for a second. It's particularly useful for use cases where you're retraining and redeploying models on a regular basis. Amazon's Pipelines is an ML CI/CD service accessible to every developer, data scientist. SageMaker Pipelines brings CI/CD pipelines to ML, reducing the months of coding needed. With just a few clicks in SageMaker Pipeline, you can create an automated machine workflow. SageMaker Pipeline takes care of all the heavy lifting involved with managing dependencies between steps of the workflow and orchestrating them. A little door here. So to manage dependencies between steps of the workflow, you have two options. One of them is you say the output of one step is going into the input of another, or you can just declare that one step should not start until another step is done, which can be important. Pipelines provide comprehensive steps from data preparation, data and transformation, algorithm, debugging, model optimization, pretty much everything you can do in SageMaker, you can add to your workflow. SageMaker pipelines keeps track of every step and includes step caching, so you can rerun the workflow at any time. If a step is enabled for step caching and its inputs have not changed, you will not pay the cost of rerunning that step. To help you get started quickly, SageMaker pipelines offer pre-configured templates for model building and model deployment pipelines. And all the templates are fully customizable. I think at this point, pipelines really means what we call SageMaker projects. And so I haven't talked a lot about SageMaker projects. SageMaker projects is something you wrap around SageMaker pipelines. We'll talk about that in a minute. So once created, the workflows can be visualized and managed in SageMaker Studio, enabling you to compare model performance so you can then select and deploy the best model for your use case. This architecture presents a SageMaker pipeline embedded inside a SageMaker project. So now I can talk about SageMaker project. SageMaker project wraps a software CI/CD framework around SageMaker pipelines, and that framework completes them. It brings everything that you want to have in it. Projects uses code pipeline, code commit, code build, and CloudFormation to wrap the SageMaker pipeline and produce the results. Projects helps organizations set up and standardize developer environment for data scientists and CI/CD systems for MLOps engineers. Projects also help organizations set up dependency management, code repository management, build reproducibility, and artifact sharing. So SageMaker projects are basically CloudFormation templates that deploy the architecture you see in front of you, including, for example, the pipeline, the event bridge, a repository in which you keep your code, and a way to deploy that code into your pipeline, S3 buckets, a model registry, and then on the other side, of the model deployment side, it orchestrates that by providing code commit for deploying the code itself, code build, so you can actually build images for doing deployment of your endpoints if that's what you need. All of this gets done through CloudFormation for staging. And then with manual improvement, you can do the same thing to deploy to production. SageMaker pipelines. So moving back away from projects to pipelines, Amazon SageMaker model building pipelines support the following step types. Well, there's 12 step types, and they're all very interesting. I've talked this morning about processing and training. Tuning is a training step that will go through a hyperparameter search using Bayesian optimization to find the best model. Model is a way of doing model creation. Transform is batch transform to do large processing, large application of a model to data. Condition is a fun one. So if you take a look at the picture on the right-hand side, you see a number of steps in a graph. The top one says pre-process, then it says train, and then it says evaluate, and then all of that goes into check Amazon abalone evaluation. That last step is the evaluation step. It's a condition step. It takes the result of evaluation and compares it to a user supplied value. And if your model meets the bar that you specified, only then will your model get registered. And so this is important. I look at the list of steps here and I see there's one step that's been left out, which is called the fail step. The fail step would be the false direction that you would take with your conditional step. That's when you don't meet the bar, what happens? And in this case, you can do many things. In particular, you can generate a message that will make clear exactly why your whole pipeline has failed. So another form and an older form of doing orchestration with AWS SageMaker is to use what's called the data science SDK. AWS Step Functions is a visual workflow service, low code or low touch, that helps developers use AWS services to build distributed applications, automate processes, orchestrate microservices, and create data and machine learning pipelines. So there are multiple use cases for this. You can automate extraction, transformation, and load of processes. You can automate security and IT functions. You can orchestrate microservices. You can orchestrate large-scale parallel workloads. So step functions, steps can execute in parallel. It's all done through a particular state function. With the addition of the step functions data science SDK, you can use this to interface with SageMaker to be able to do most machine learning steps. And I'm 2 minutes and 1 second. Amazon Managed Workflow for Apache Airflow. For machine learning, you can use Airflow to orchestrate tasks, but you typically want to execute machine learning tasks remotely. So in the context of SageMaker, we have SageMaker operators for manage workflows for Apache Airflow. As a point, as it says here, you can actually also use these operators with just regular Apache Airflow. The difference between managed workflows for Apache Airflow and just plain Apache Airflow is managed workflows lets you deploy Apache Airflow and then takes care of managing it for you. So you don't have to do the undifferentiated heavy lifting. You get all the benefits of Apache Airflow without the pain. So there are SageMaker operators for Apache Airflow. So there are special operators, and there's also Python operator, an Airflow built-in operator that executes Python callables. You can use Python operator to execute operations in the SageMaker Python SDK, or to create a SageMaker workflow. So, right. So there's an entire AWS Airflow stat that you can find, and I can provide you with a link for that. So then there's a question, so Apache Airflow is an open source tool. So when I'm saying orchestration with open source tool, I mean to say more on the end of Kubernetes. So SageMaker interfaces in two ways with Kubernetes. There's AWS controllers for Kubernetes, which are a great library of ways of calling SageMaker from Kubernetes. And then there's AWS components for kubeflow pipelines. So AWS controllers for Kubernetes lets you define and use AWS service resources directly from Kubernetes. With ACK, you can take advantage of AWS managed services for your Kubernetes applications without needing to define resources outside of the cluster or run services that provide supporting capabilities like database or message queues within the cluster. Then, of course, there's SageMaker with kubeflow. So that would be the obvious comparable to step functions or SageMaker pipelines or code pipeline. Kubeflow is a platform for data scientists who want to build and experiment with ML pipelines. Kubeflow is also for ML engineers and operational teams who want to deploy ML systems to various environments for development, testing, and production level serving. Kubeflow features easy reuse, enabling you to reuse components and pipelines to quickly create end-to-end solutions without having to rebuild every time. Kubeflow has different components, but I'll mention only the ones that feature native integration with SageMaker, which is Kubeflow Pipelines. So Kubeflow Pipelines is available as a core component of Kubeflow or as a standalone installation. Kubeflow pipelines were still in the beta mode a while back, but they provide a platform for building and deploying portable, scalable machine learning workflows on Docker containers. You can use the EI, the Kubeflow Python SDK, or REST API to build and integrate your pipelines. A Kubeflow pipeline is a set of code used to execute one step of a Kubeflow pipeline. With these pipeline components, you can create and monitor native SageMaker training, tuning, endpoint deployment, and batch transform jobs from your Kubeflow pipelines. By running Kubeflow pipeline jobs on SageMaker, you move data processing and training jobs from the Kubernetes cluster to SageMaker's machine learning optimized managed service. So then comes the question of reproducibility. So let's take a look first at what we can do with native AWS services. So again, could the microphone on the desk be muted on the table? Is that the room microphone?
Yeah, just muted.
Thank you. So the way of getting reproducibility is SageMaker experiments. Experiments allow you to track and manage experiments. An experiment is a combination of, we used to call them trials, but now we call them runs. Trials have trial components and also have trackers, and the trackers include parameters, inputs, outputs, artifacts, and metrics. So it's basically one large bushy tree of possibilities. So you can track thousands of training experiments to understand the accuracy of your model. For each trial, you would have parameters, inputs, outputs, artifacts, metrics that have been recorded, and you can look at them inside of Studio and compare them, or you can do them from outside of Studio also. It's important to understand that SageMaker experiments is not tied to SageMaker Studio. It's enhanced by SageMaker Studio for doing displays. So you can use SageMaker experiments just when you're using SageMaker at all. You can just use it where you need to and not inside of Studio. Once once models are provided to your once I'm sorry once the um, once this capability is provided to your data scientists, then your data scientists move their models through CI/CD pipelines by approving them within the model registry. There is also, so approved, if you take a look at the image here, there is a little column that says status, the second column from the left. And you can see that there is a rejected model and there's a bunch of approved models, which is nice. There's also the stage or step that the model is at next to it. So you see some model was in staging and that's where it got rejected. This model is in production. And then there are other models that are archived. So you can provide a stage to your model for doing tracking. The great part about all this integration with SageMaker Studio is you can take advantage of the single pane of glass that SageMaker Studio provides. So after your model gets deployed to production, or right, you can see the results about these models right within Studio. So SageMaker Model Registry will let you compare and contrast results you get from models. So SageMaker Pipelines then is fully integrated with SageMaker Experiment. Every time you run a pipeline, that pipeline will create a new experiment if you need one, or if you supply it with an experiment, we'll use that experiment for you. And then you can compare trials from the same or different pipelines, either by pulling their information through the SageMaker SDK or the AWS CLI or in SageMaker Studio. And you can link these executions using SageMaker Model Registry. Every pipeline execution can be linked through Model Registry. So important to reproducibility is lineage tracking, something that I mentioned were the parts that were obtained, the artifacts that were obtained. Amazon SageMaker machine learning lineage tracking creates and stores information about the steps a machine learning workflow went through from data preparation to model deployment. With the tracking information, you can reproduce the workflow steps, track model and dataset lineage, and establish model governance and audit standards. With SageMaker lineage tracking, data scientists and model builders can keep a running history of model discovery experiments, establish model governance by tracking model lineage artifacts for auditing and compliance verification. The following diagram shows an example lineage graph that Amazon SageMaker automatically creates in an end-to-end model training and deployment workflow. So a key thing to know about here is I don't believe SageMaker Studio includes a component to display the lineage metadata in this form. So this is a nice picture, but for things to be clear, you're not going to open SageMaker Studio and find the ability to see the lineage metadata in this form. But you can see the lineage metadata by navigating it using the interface in SageMaker Studio. Another key component of the deployment story is the use of Amazon SageMaker Feature Store. The Feature Store is a fully managed, purpose-built repository to store, share, and manage features from machine learning models. The key selling point about Feature Store is that it links training to deployment. When you use a feature store to ingest data for training, and you use the same feature store for inference, you're using the same features on both sides. Features are inputs to ML models used during training and inference. So, for example, if an application recommends a music playlist, the features can include song ratings, listening duration, and listener demographics. The features are used repeatedly by multiple teams, and feature quality is critical to ensure a highly accurate model. Also, when features used to train models offline in batch are made available for real-time inference, it's hard to keep the two feature stores synchronized. SageMaker Feature Store provides a single source of truth, a secured and unified store for feature use across the entire ML lifecycle. So how do you do this with open source and third-party tools? ML flow tracking component is an API and UI for logging parameters, code versions, metrics, and output files when running your machine learning code. MLflow is an open source component that was created by Databricks, and Databricks put it in open source. You can use MLflow with any machine learning process. You should um, instrument the process itself with pieces that capture the parameters, code versions, metrics, and output files. MLflow tracking lets you log and query experiments using Python, REST, Java API. Recently, MLflow's capabilities have been augmented with the ability to deploy MLflow models to SageMaker. This is relatively easy. MLflow has a SageMaker component that lets you automatically use MLflow within SageMaker components, such as SageMaker pipelines. Do you want to speak up about this, weights and biases?
This is your moment.
What should I say?
Y'all, this is your chance. You can talk about what it is that I'm showing and what I left out.
Oh man, I don't think I left anything to. I don't know. We just saw a demo, I guess.
Cool.
Yeah. No, you did. You summarized it perfectly.
Okay. So that's the end of my presentation. Thank you, everyone. Do you have any questions?
Yeah, for questions, just unmute and speak up. It's probably the easiest. Sanjay, looks like you have a question. Maybe not. Well, in that case, oh, I see. In that case, let's start setting up for the AnyScale demo, hands-on. And I think it might also make sense to do a 5-minute bio break. Is that good? Okay,
That
so
makes a lot of sense.
Yeah,
Let
so
me
we'll
add,
stay.
just before I go, my email is on the screen right now, and I'm going to leave it there until somebody knocks it off. If you have any questions that occur to you afterwards, feel free to reach to me and ask them about everything that I presented today.